So welcome everyone. I'm really happy to see you all here. We are going to present today about the Event-Driven Architecture 2. That is a continuation of the EDA 1 that we talked about scalability, decoupling, and how can we increase our pipeline's performance and drive through good architecture, okay? Today we're going to talk about how can we use event-driven architecture to create pipelines and patterns that could save the developer some time in the workflow. So for example, if you spend uh, a lot of time doing repetitive processes like reprocessing, we are going to see how can we use that time in an efficiently way. So before I start, let me present myself. My name is Danilo. I am instructional developer from education team. And I'm here with Lucas. He's also an instructional developer. And we are going to present this webinar for you now. So thank you for being here and let's get started. Before starting, let me ask you something. Have you watched the EDA1 webinar? And I will ask you to raise your hand if so, because that answer will help me to understand if I need to be more detailed about the use case, because we are going to use the same use case and continue to improve it, the same use case of EDA1, okay? Just 30 seconds for you to raise your hands or just answer the poll here. The last use case, we use it, okay. A lot of people I have already watched the EDA one, but I will try to explain a little bit about that use case and pass through the pipelines so you can understand everything without missing nothing, okay? So let's get started. For our agenda and objectives, we have this. So the first part of this meeting is about reintroducing the use case from EDA 1, since we are going to use that use case and improve that one. We are going to review the opportunities of the previous integrations, and we're going to see that the integration of the last use case is already have a good architecture, but we can improve some pipelines and maybe create another pipelines for not wasting some time doing that processes I have told. And present the pattern. So basically, if you are going to create another pipelines, I'm going to present you the patterns of that pipeline. So why we want to create this and what should it look like, because it's a pattern, so it has some kind of format, and I'm going to show for you. And to do this, we need to first adapt the pipelines. So we need to create a state machine, and a state machine is basically a machine that have the records of the integration and all its fields, the status, the date, the creation date, the last update date. So we can use that fields to create more powerful integrations and have more traceability of the data. And with that state machine, we can create the pipelines. So Lucas will help me with that. He's going to show for you the pipelines we are going to create. And the last part of the meeting, I will show you the state machine we created. I'm going just to present the pipelines, but I will create or something like this with you in the last part of the meeting. And in the Q&A session, we are going to open for asks and discussions, and you can post your questions in the chat or in the Q&A tab in the Google Meet, that in the right spots, we are going to open and discuss about what are you asking, okay? So let's get started. The first part is reintroduction to the Clara story and the project. That's the same use case as the EDA one. So let's go. Clara, a talented developer, was hired for a data processing project by a healthcare company that needed to verify the authenticity of invoices to reduce costs associated with paying fake invoices. So that healthcare company needs to pay invoices, and some of that invoices are fake, so that the company is wasting money paying that invoices. And because of that, that company decided to utilize on its artificial intelligence servers to recognize the validity of invoices. So that AI servers are going to receive that invoice. It will analyze that invoice and return for us the field's authenticity. And we want to use that field authenticity to calculate if that invoice is fake or not. And Clara integration architecture worked as follows. The first part of this is basically retrieving IDs, and each ID represents one invoice. But we need to be careful because ID is not the invoice itself, it just represents the invoice. And after retrieving that information, that IDs, each ID have a field called integration status. And the integration status could be pending, processing, failed, approved or disapproved. And the last two, approved or disapproved, means the invoice is genuine or it's fake, for example. And because of that, we are going to retrieve that IDs. And for each ID, we're going to download the invoice itself. So with the PDF file that represents the invoice, we can send to the AI service. And the AI service will take some time to process it. And after processing it, AI service will call DGB again through a webhook. And that webhook will receive the analysis of each invoice field's authenticity. And we're going to use that data to calculate if the invoices are fake or not inside the DGB. Okay? So in that third pipeline, we are going to do that calculations and set in the database of IDs if the integration status is approved or not approved. And then the healthcare company can decide if it will pay the invoices or not. And because of that, it will not waste a lot of time. It will save money by doing this. So let me show you the 3 pipelines that Clara built to create that integration. The first one is that. So scheduler consult invoices. It is a scheduler that activates each minute. That strong expression basically represents each minute that integration will start. And as you can see, we have a page size that represents that she created a pipeline that is using pagination technique. Inside this component here, we are going to see that we are retrieving 30 records. So each minute, we are going to retrieve 30 records. And inside of the configuration of that string DB, that is basically a DB connector and a for each connector at the same time, we're going to select the invoices table. And an important thing here is that we are going to use just the integration status pending for that retrieving. And we are limiting that database with the page size I showed before. So if we are just retrieving the pending voices, it means that the pagination is already working without any other configuration. If I go inside the on process here, we're going to see that for each invoice, we are publishing an event, and that event represents the processing that I told of downloading a PDF and sending to AI service. And we are going to see that pipeline too. But before starting, let me just executing that pipeline here. So for example, if I cut that error here and execute the pipeline, it probably will show 30 records, just like that. And in the message, we can see that we are receiving an ID that represents the invoice and the integration status of that invoice. So you can track if it is pending, processing, approved, failed, or disapproved, for example, and the creation and updated timestamps that represents that invoice inside the database. So now let's go to the second pipeline. The second pipeline is the EVT invoice processing. It is an event as trigger, and we are listening to the same invoice that were published in the last pipeline. So for each record that is being published in the last pipeline, we are going to activate that one here. And we are going to set the integration status to processing. And because of that, we can track the record inside the integration. And with the ID we receive it and resave it in the session management, we can download the invoice.pdf here. And as we are calling an external service, we need to verify if it was successful or it failed. And if it failed, we can update the status to failed. But if it's success, so we can send that invoice that we downloaded through to the AI service that we call OCR. OCR because of optical character recognizer. And since the AI service takes some time to process that invoice, we are not waiting for that response here. We are just waiting for the response of, okay, my invoice was sent to the AI service or not. Not. It has some errors, so update status failed. But if it's okay, so we're going to just set a message here. For example, invoice accepted by invoice recognizer. And the AI service will take some time to process it, and then it will call DGB again through a webhook with the fields that represent the analysis. And that's the third pipeline. So the third pipeline, the API webhook invoice results, it is an API because it's a webhook, and it will receive the information of the processing in the AI service. And because we are receiving some information from another service, we need to validate the return. So we are going to validate with a validator component with JSON schema, some fields, for example, tax amount, protocol ID, total amount, and others. They all are required in the system, and we need to verify its types too, if it's a string, a number, or any other type format. And if everything is okay, so we can calculate the reliability of that invoice. And that JSON generator could represent anything you want. Basically, it's an average of all the fields of the invoice, the veracity of all the fields. And if this average is basically more than 7, for example, we can set this invoice as available. If not, the availability is too low. And with that information, we can update the database again. And the database would be, for example, integration status to disapprove it or integration status to approve it. Okay, so that's the 3 pipelines of the event-driven architecture 1, the last use case represented. And now we are going to understand what could be improved in this architecture. So event-driven architecture 2 is about to take all this integration here and understand what could be improved. And we need to understand that we want to save some time, mostly of the devs, because if the devs have more time, they could use that time to create another integration and move your company through digital transformation faster. So it's a good thing to have more pipelines to create automatized routing of your developer. Okay, so coming back to the presentation, that's how the Claris integration solved the problem of the healthcare company. And I want to invite you to understand what improvements have you identified in the current architecture. And when I mean the current architecture, I mean not focusing on components configuration, is what can I do, what can I build another pipelines or another architecture that can improve my integration. And meanwhile, I will present that tab here that I've presented in the last webinar, that is basically the integration working visually. So we have the invoices, pending, processed, failed, approved, or disapproved, and we can see it working because our integration is deployed. So you can see the approved or disapproved or anything like that. So what happened if an invoice is with failed integration status? What happened? Because for now, we are just approved or disapproving invoices, and then we are not reprocessing anything. So failed invoices will become failed forever, and the health company will just ignore them. So that's the first problem. And in that history that we are telling, Clara need to reprocess it every day. So she needs to go to the platform. She needs to go to the first pipeline, that is the scheduler that retrieve the IDs, and change the SQL statement to transform in select in the voices table the integration status failed, and then she will send all the failed invoices to process again. But it will work for some records, but it's not the best option for us because first, she's wasting her time in reprocessing. This is a manual task that could be easily created another pipeline to do this for her. The second problem is basically if the invoice have some problems in these fields. So it means, for example, we send an invoice to the AI service. The AI service send us back the reliability of the fields. And we're going to understand that it's missing an important field. And because of that, the integration failed. But no matter how many times I process it again, it is always without that field. So we are going to reprocess it infinitely. So it's not forever. It's not a good option to just reprocess it manually. That's the second problem. The third problem is we have the invoices in approved, disapproved, or failed forever. So basically, with days, with months, and maybe with years, that database will be congested because of this data contained without being deleted. And the performance of our pipelines will decrease because of that. So we need to create a routine to delete the information from the database because it's not useful anymore. Another problem is basically, imagine that the AI service is now is down for now. So it's not working. The system is down. But independent of the AI service, my database will be retrieved, the data will transform to processing status, and in the processing status, we are going to fail it because the AI service is not up, the system is not up, and we are going to increase that stack of failed invoices, and that is a problem. What if I just notify, I alert some stakeholders of these integrations, and in that alert, I say that spot here, that system here is not working well, so they can act quickly and avoid some problems like a lot of fade invoices and other things like that. And the last point, I think, is the fifth one. Clara needs to do a report daily of all this integration. So which records I processed today, which records failed and got an error, for example, and is not being reprocessed. How can we store that information in another system for a BI service, for example? So we have a lot to do here, a lot of improvements. That is about architecture. It's not about components. It's about how our data is going through another pipelines, but maybe stopping in some pipeline and do nothing more, or how the Clara needs to use her time to do some manual tasks, and we want to improve the architecture because of that, to avoid these problems, avoid these inefficiencies. So coming back to the presentation here, Clara identified critical issues in her workflow, such as potential data loss during integration, manual word processing, and daily self-reporting of results. This practice led to inefficiencies, data inconsistencies, and lack of traceability, and we need to solve this. And in order to address this challenge, she decided to utilize the benefits of event-driven architecture again to create standard pipelines. And when I say standard pipelines, is that pipelines I told you before. And here's how she approached each topic. And for that, I will call Lucas, my colleague here, and he's going to present that pipelines for you. Go ahead, Lucas.
Hey everyone, good afternoon. I'm going to show you guys how Clara solved all these problems using again the event-driven architecture. And we are going to take a look at the bigger picture here. And as Danilo said before, the event-driven architecture has its benefits. You can achieve more performance, you get more speed, you segregate responsibilities between the pipelines, and much more. But we have to take care not to leave behind on the road some manual tasks while we are implementing this kind of architecture. So I'm going to present my screen here. Let's take a look here on the bigger picture. So when Clara got in front of these problems, she realized that she has to do more manual tasks on the decoupling pipeline than what she was doing before. So the first pipeline is processing all the data here. And when the data gets stuck, it is separated in a different stack of errors that we have registers that have errors that are saved in a different database here. So Clara has to manually get this data and reprocess it by herself. Had to do this daily. So she decided to take another approach, that is build a reprocessing pipeline that we call here the pipeline number 3. And this reprocessing pipeline, it gets this stack of errors from a predefined period. So here we have 3 in 3 minutes, but it can be 5 in 5 minutes, or it can be in a specific time of the day. And it keeps looking at the error stack database and keep watching. And if you have any errors, it brings the error again to the processing queue. And we are going to take a look right now at this pipeline. So we have here the reprocessing pipeline, and let's take a look here how it works. So we have this trigger here. So for 5 to 5 minutes, it gets into this database where it queries all the integration status equals failed. So when a register, we are trying to process a register on the previous pipeline that Danilo showed you guys, and it gets some error. It changes the integration status to failed and saves in this separated stack here. So when we begin reprocessing, every 5 minutes, we take a look on this database and pick it up those records and send them to the processing pipeline again. So first things first here, it checks if there are any records on the database, and if there is no records, it returns the output message to the user saying there is no records to reprocess. Okay. If some records are returned, it enters here in a for each loop, and for each record, it will add a try to the record. So when I say it adds a try to the record, it's because when we are decoupling those pipelines and segregating responsibilities, primarily when we talk about the reprocessing pipeline, we benefit for a massive range of opportunities here. So one of these opportunities is to increase some parameters and take control of more things here about those records. So Clara can establish now a number of tries to these records to be reprocessed. So she says here that we have to try 3 times to reprocess each record. So it sends every time a record passes here, it adds 1 to the number of letters parameter and checks again. So it's some 1 here and checks. So if we reach the limits of tries, so limit of tries reached, it goes to this road here and updates the integration status to error. Okay. If the register do not reach the number 3, so it goes down here and we publish, here's the events, we publish the dynamic events again to the processing pipeline. So as long as this guy is below the number 3 of tries in his parameters, it is eligible to send to process again. Okay, so it happens like this, and we set a success as true as a summarize of what is happening here. Okay, so Clara solved 1 manual routine here. Now she does not have to daily enter into the database pick those records that has not been processed by some way, and manually send them to the processing pipeline. Okay, we solved one manual routine here, but as I said before, when we are implementing the event-driven architecture, we have to pay attention, because we can create a kind of a Frankenstein of manual tasks here that we create by default when we are implementing this. So what I ask you guys here is, every register that passes here, it gets one summed to the number of tries. What happens when a register reaches the number of tries, reaches the limit? It gets the integration status to error and keeps stuck here in another stack of errors. So another manual routine Clara would do here is to check, manually check those registers that are not processing by any way. So maybe by some bigger error or something like this, these registers are not being processed, and they are reaching the limits of process established by our developer here. Clara has to check manually and pick those guys and make some kind of report, alert the stakeholders, and alert the owners of this integration or her client, and she has to make a report for it. We can solve this manual routine. Taking a look here at the bigger picture again, I will show you guys. Clara created, here you can see on the right, pipeline number 4. So she created another pipeline that she calls the report pipeline. Pipeline number 4 is scheduled to run every day at midnight. What this pipeline do is to save a report into a Google Drive folder containing those records that are not being processed by any way. The process reaches the limit of reaches established by our developer are not being processed anymore. We save this as a report in a Google Drive folder. So let's take a look on this pipeline number 4. She called it scheduled midnight integration report. So when we take a look at the trigger here, we see it is scheduled to run every day at midnight. And it is a simple pipeline. It just gets all error records. So it enters into the database and get all records that have the integration status equals error. So we know that those guys here are records that entering into the processing pipeline for 3 times, and for some reason they are not being processed. So it turns into a CSV model here. So it picks the error stack and turns into a spreadsheet and saves into the Google Drive here error stack folder. We'll see very soon how this Google Drive folder helps us to keep the flow on the event-driven architecture that Clara is implementing here. Again, Clara sees the bigger picture, and she sees that even implementing the event-driven architecture and benefiting from it, she can see manual routines and some gaps that she can fill using the event broker here. So she is already reprocessing records with errors. She's already saving a stack folder as a spreadsheet on the Google Drive. She is already dealing with reprocessing and reporting. Another manual task that Clara can solve using event-driven architecture here is alerting the owners of this integration, in the case of her client, about what is happening here. So every time we get 3 attempts to process a register and it is not processed, it saves the file and we have to alert someone. Again, she can manually do this. She can pick off, download this spreadsheet and send by email to the stakeholder, but she can use event-driven architecture to automatize it. So when we back here, we see that we have a pipeline number 5. That is a pipeline of notification. It is the last pipeline of the architecture that we have here. It is a pipeline that notifies the owner of this integration about what is happening. So let's take a look here So we have this, the event alert stakeholders pipeline. What we have here is a pipeline that receives some parameters here. So Clara can establish some parameters like the origin of the error stack. She can decide if you will send an email to the stakeholders or will be a Slack channel message. We can open up those range and we can put to a WhatsApp message or a Telegram message or something like this. It depends on the developer's choice. So here, Clara put for us two options. So we can alert the stakeholders by email, or it can be a Slack channel message. Another parameter that receives here, if it has a file or not. Okay, and we'll see very soon how we check if there's a file here. We put here to the text that will be the body of the email or the body of the message of the Slack, and the emails that we are going to send this summary of errors. And here's the channel, the code of the channel that we are going to put the message on the Slack if the destination is Slack. So, okay. First things, it receives an event here and it groups the inputs here. So we have a input object here and saves into the pipeline context. When we enter here at this block execution, we can check if there's a file or not here. So let's take a look here. We enter here and it verifies if this alert has a file attached to it or not. If has a file, it enters to our Google Drive folder that we said before. Retrieve all files, gets the last element of these files, and download it to our pipeline. So we save the file name here on the context of our pipeline, and this file name is on the GGB context here on the platform. Our file names is the file directory 2. So we have by saving the name, we are pointing a file directory here. So after it saves the file, it checks what is developer's choice to alert his stakeholders here. So if the choice is an email, it will ungroup the inputs and turns into a whole message, and we'll choose here if we'll send with the file attached or we'll send only the message. In case of a file, we'll pick the file name here and we'll send a dynamic email to our stakeholder here with our body, our subject, and the file attached that we have been downloaded by the Google Drive folder. So if the developers choose to alert the stakeholder by a Slack alert, for example, it will just send by REST call here to our Slack using the Slack number that we've seen before, and we'll put the file, the text, and the channel here, and we'll send to the Slack, and our stakeholder will receive by Slack message the file and the message. So why do we have this structure here? This is to Clara to avoid manually alert her stakeholders about the errors that have been occurring. So when we back to the bigger picture here, we see our whole architecture here, the whole machine working using event-driven to functioning. So we have the pipeline number 1 that queries the database. For each record that it queries, it triggers an event sent for processing. In case of error, the registers with errors are saved in a different stack of registers. And we have a pipeline number 3 that is automatically searching for 5 to 5 minutes or 3 in 3 minutes into this database and getting those records with error and sending them again to the queue. When we reach 3 attempts, so for some reason these records are not processing, so we have the pipeline number 4 working too, that every day at midnight will send the file to the Google Drive folder and will clear the record from the state machine so we can keep the database healthy. So send the report by email using the pipeline number 5. That is the pipeline notification. So when we take a look here, we have every pipeline with its own responsibility. So we have a pipeline to query and send, we have a pipeline to process, and we have some pipelines, auxiliary pipelines here that is to reprocess, save reports, and send notifications to the owners of the integrations. Okay.